Hello, today we are going to discuss about the law of conservation of linear momentum. Today's topic is law of conservation of linear momentum. It is from Chapter 5 of NCERT textbook volume 1. Okay? What is the law states? The law states that in an isolated system, total linear momentum of the system remains constant. In an isolated system, total linear momentum of the system remains constant and is not changed due to the mutual action and reaction or due to mutual attraction and repulsion between the bodies constituting the system. So isolated system means in absence of external force. তোমালোকৰ ক্যারাম খেলা মনত আছে ক্যারাম খেলুতে আমি কি কৰো before the game starts we use the boric powder so that the surface becomes smooth. If a surface becomes smooth, then what happens? Force of friction eliminated. That means we try to remove the external force before we start the play. So here also, in absence of external force, that is called isolated system. Total linear momentum of the system. And the system consists of two particles here. The system consists of two particles. Total linear momentum of the system, where the system consists of two or more particles, remains constant and is not changed due to their mutual attraction and repulsion between the bodies constituting the system. If you see in our case, our system consists of two bodies, body A and body B. Body A has mass m1 and body B has mass m2. They are moving along the same straight line with velocities u1 and u2. Now, if u1 greater than u2, then what happens? After some time, body A hit body B. Body A hit body B. So, this is the condition of hitting. Body A hit body B. When body A hit body B, it exerts the force on body B, which is given by FAB, which is equal to FAB. FAB, you can read here also, FAB, what is FAB? Force on the body B due to the body A. This is action. Since velocity of A is more than velocity of B, after some time A hit B. When A hit B, it exerts a force on B, which is called FAB. Which is called FAB. You just say, what is FAB? Force on body B due to body A. So this is action. We know that to every action, there is an equal and opposite reaction. There is an equal and opposite reaction. To every action, there is an equal and opposite reaction. So if this is the action, B also gives a force on A, which is called reaction. This force here we denote as FBA. FBA. What is FBA? It is the force acting on body A due to body B. What is FBA? You just see force on body A due to body B. Initially A exerts the force on B, this is action, and B gives a reactional force on A. that is FBA. FBA means force on body A due to body B. And due to these forces, after some time the body gets separated and move with velocities V1 and V2 along the same direction. You just see what is V1, velocity of A. After they get separated, what is V2, velocity of B. Therefore, it is written that this is the body A and B moving with velocities U1 and U2. Moving with velocities U1 and U2, this is before collision. Here, A exerts a force on B, B gives a reactional force on A, this is during collision. And due to these forces, the body gets separated and move with velocities V1 and V2 along the same straight line. So therefore, this is after collision, this is during collision. You just see another term is written here, time of contact delta T. That means during the collision, when A hit B and B gives a reactional force on A, during that period, the two body remains in contact. And what is that time interval? I call this time interval as delta T. That means during this time delta T, velocity of A changes from U1 to V1 and velocity of body changes from U2 to V2. Why the velocity changes? Because momentum of the body A and B changes. Why? Due to the application of these two forces. Now, what is Newton's second law? What is Newton's second law? The applied force is equal to rate of change of linear momentum of the body. If a force acts on a body, momentum of the body, when a force acts on a body, momentum of the body changes. But what is the applied force? Applied force is equal to rate of change of linear momentum of the body. Newton's second law states that rate of change of linear momentum of a body is directly proportional to the applied force on the body, and change of momentum takes place along the direction of the force. Okay? Is it clear? So you may ask another question here, from where this force comes? Because we say that in an isolated system means in absence of external forces. From where these two forces comes? That means according to you, these two forces must be zero. When I add these two forces must be zero. Because in absence of external force means what? There is no force. But I have written these two forces FAB and FBA. If I add these two forces, it must be equal to zero. Because in absence of force, so therefore I put FAB plus FBA is equal to zero. From here what I get? FAB is equal to FBA. So this is the Newton third law. This is action and this is reaction. Action and reaction are equal and opposite, but they never act on the same body. You just see where action act on body B, and where the reaction act on body A. Now, according to Newton's second law, this force is equal to rate of change of linear momentum of the body B. This force FAB is equal to rate of change of linear momentum of body B. Why? Because this force acts on body B. You just see force on body B due to body A. I call this FAB. Due to this force FAB, momentum of the body must change. And Newton's second law states that FAB is equal to rate of change of linear momentum of body B. And FBA act on body A, FBA act on body A, FBA act on body A. Therefore, FBA is equal to rate of change of linear momentum of A. FBA is equal to rate of change of linear momentum of A. Now, what is the initial momentum of B? It is m2u2. Initial momentum of B is m2u2. What is final momentum of B? m2v2. m2v2. In what time this momentum changes? This momentum changes in time delta t. In time delta t. Therefore, according to Newton's second law, FAB is equal to m2v2 minus m2u2 divided by delta t. What is FAB? FAB is the force acting on body B. Newton's second law states that applied force is equal to rate of change of linear momentum of the body B. This is the force acting on body B. Therefore, momentum of body B changed. What is the final momentum of body B? m2v2. What is initial momentum of body B? m2u2. So, what is change of linear momentum of body B? m2v2 minus m2u2. In what time momentum changes? In time delta t. Therefore, FAB is equal to rate of change of linear momentum of body B. So, this is the expression of FAB. Now, what is FBA? FBA is a force acting on A. As a result, momentum of body A changes. So, what is final momentum of A? m1 v1. What is initial momentum of A? m1 u1. So, what is change of momentum of A? m1 v1 minus m1 u1. So, you just see. What is initial momentum of A? m1 u1. What is final momentum of A? m1 v1. So what is change of linear momentum of A? What is change of linear momentum of A? m1 v1 minus m1 u1. So, in what time momentum changes? In time delta t. This is m1 v1 final momentum of A, m1 u1 initial momentum of A. Therefore, m1 v1 minus m1 u1 gives the change of momentum of A. In what time momentum changes? In time delta t. Therefore, what is FBA? FBA is m1 v1 minus m1 u1 divided by delta t. These two expression of force, we have to substitute it in this equation. We have to substitute FAB and FBA in this equation. When we substitute these two forces, what we get? What we get? We are getting this. You just see. m2v2, FAB is m2v2 minus m2u2 by delta t, and FBA is equal to m1 v1 minus m1 u1 by delta t. Side one. Side one. Okay, I substitute these two forces here. This delta t, this delta t get cancelled. A duta delta t cancelled hobo. A duta delta t cancel hobo. I remove the bracket, minus m1 v1 minus minus plus. Okay, this is taken on this side, minus m2 u2. If I bring it right hand side, it becomes positive. Minus m1 v1, if I take it on the left hand side, it is positive. Okay, now I return this part here, I return this part here. What is m1 u1? m1 u1 is the initial momentum of A. What is m2 u2? Initial momentum of B. Therefore, m1 u1 plus m2 u2 gives you linear momentum of A and B before collision. What is m1 v1? Final momentum of A. What is m2 v2? Final momentum of B. So m1 v1 plus m2 v2 gives you final momentum of A and B. They are equal. Have you seen? They are equal. That means in absence of external force, total linear momentum of the system remains constant. Our system consists of two bodies A and B. This is linear momentum of A and B before collision. This is final momentum of A and B after the collision. That means in absence of external force, linear momentum of the system remains constant. But in this case, you may argue in one way. তোমালোকে ইয়াত এটা কথা ক'ব পাৰা যে here momentum of B increases, momentum of A decreases. In our case, momentum of B increases because in order to get separated, body B and A, velocity of body B must be greater than velocity of A. That means momentum of B increases and momentum of A decreases in our case. But amount of increase of momentum of B is exactly equal to the amount of loss of momentum of A. Is it clear? Momentum of B increases, momentum of A decreases. But amount of increase of B is exactly equal to the amount of decrease of A. As a result, what is change of momentum? What is change of momentum of A and B after the collision? It is equal to 0. Change of momentum of A and B after the collision is equal to 0. Change of momentum 0 means key. Final momentum must be equal to initial momentum of A and B. Change of momentum of the system is 0 means what? The final momentum of A and B must be equal to initial momentum of A and B. That means when capital A hit capital B, their individual momentum changes, but total change of momentum of the system as a whole is equal to 0. Therefore, final momentum of the system is equal to initial momentum of the system. That means amount of increase of momentum of B is exactly equal to the amount of loss of momentum of A. Is it clear? So this is called law of conservation of linear momentum. In absence of external force, total linear momentum of the system consisting of two or more particles or bodies always remains constant and is not changed due to their mutual attraction and repulsion of the system. Due to their mutual action and repulsion of the bodies constituting the system. Okay?